Our first topic is graphing polynomial functions. A polynomial function is an expression that can have constants, variables, and exponents that can be combined using addition, subtraction, multiplication, and division. Our problem is fx equals 2x times x plus 3 times x minus 1 times 2x minus 1 to the power of 3. As you can see, the zeros of the function are 0, -3, 1, and 1/2. Depending on the multiplicity of zeros, you get different effects on the graph. 1 means cross, 2 means bounce, and 3 means wiggle. To find the end behavior, take a look at the leading coefficient. In this case, the coefficient is even and positive, meaning the end behavior is down up. To find the y-intercept, plug 0 into all x's, so in this case, that intercept is at 0, 0. And lastly, to find the power function, multiply all the x's in the function along with their corresponding coefficients and powers. In this case, the power function is 16 to the power of 7. To graph, locate all your zeros on the x-axis and use the corresponding effects. Our next topic is graphing rational functions. A rational function is a function that has a ratio of two polynomials. Our problem is f of x equals -2 times x squared minus 4 over 3 times x squared plus 4x plus 4. To easily find out the information of this function, we insert it into a graphing calculator. Looking at the graph, we can easily eye out the vertical asymptote where the lines don't meet vertically, and the horizontal asymptote where the lines don't meet horizontally. From there, we can say our domain is -infinity, -2, union -2 to infinity, and our range is in -infinity, -2/3, union -2/3 infinity, because -2 and -2/3 are excluded from the graph. One final thing you can see from the graph is the x-intercept of 2 and the y-intercept of 2/3. Our next topic is graphing trigonomic functions. A trigonomic function is a function of an angle using trigonometry, including the sine, cosine, tangent, cotangent, secant, and cosecant. Our problem is y equals cosine 3x plus 2. So looking at our function, we can find a few things to help us graph. The 3 inside the parentheses represents our period, and the 2 represents our vertical translation. And because the coefficient of our cosine is 1, the amplitude is 1. Because our vertical translation is plus 2, move our wave from 1 to 3. And because our period is 3, that means our wave will make 3 complete bounces in one period. Graph this accordingly, and we can see our range is 1, 3. Our next topic is solving an exponential equation. An exponential equation is an equation in which variables occur in the exponent. Now, exponent equations can be solved with or without logarithms. To start off, our logarithm problem is 10 times e to the power of 10 minus 3m minus 8 equals 23. So our goal is to isolate the m. For starters, we can move the 8 over to the other side and divide that side by 10. Next, we divide both sides by the natural log of e. Then subtract the other side by 10 and divide it by -3. Our next problem without logs is 64 to the power of 2x divided by 16 to the power of 2x plus 3 equals 1. To begin, we change 64 and 16 to become the same base. This changes them to 2 to the power of 6 and 2 to the power of 4 respectively. Next, combine the exponents and subtract 2x by 8x plus 12. Combine these exponents and change the base of the 1 to 2. Set the exponents equal to each other and solve. Our next topic is solving logarithmic equations. A logarithmic equation is an equation that contains logarithmic expressions and constants. Our problem is log 4 times x squared minus 3 plus log 4 times 10 equals 1. Since we have the same base, we can get rid of those logs. Next, we distribute the 10 and add 30 to the other side. Divide the other side by 10, then find the square root of 3.1. Our last topic is trigonometric proof. And what this means is equalities that involve trigonometric functions. Our problem is cotangent x plus tangent x equals secant x times cosecant x. First, we focus on one side. In this case, we're going to focus on the left. Change the values of cotangent and tangent to cosine over sine and sine over cosine respectively. Next, cross multiply and simplify. Change this into 1 over sine times cosine. Then separate into different fractions and change them into their equivalents, leaving you with the solution secant times cosecant.